Okay, so this is the lesson, and last lesson of Unit 7 on solving logarithmic equations. Similar to the previous lesson when we were solving exponential equations, there are similar properties that you can use to solve log equations that you used to solve exponential equations. And the first one is the property of equality. If you remember with exponential equations, if they had the same base, then you could just simply set the exponents to each other. Similarly, with logs, if logs have the same base, then you can just set whatever the log is equal to each other. For example, if I have two logs of some base, and they have to be the same base. So we notice here that both of these logs have the same base. Then it is simply, let's put then x equals y. You would just set the whatever the log is of, and you set these equal to each other. So it's the exact same as the property of equality for exponential. So for example, if I had log base 2 of x equal to log base 2 of 7, since both of them have the same base, I would just set the whatever they're logging to each other. So this would be x equals 7. So it works with logs. It also works with natural logs too. As long as they have the same base, then you can apply the property of equality. So we'll look at the first example here. We have natural logs, and natural logs, if you remember, let me zoom in here, have the same base e, so we can apply the property of equality. Since you have logs of the same base, we can just set whatever they're logging equal to each other. So I have 4x minus 7 equals x plus 5. And then solve. Subtract the x over, add the 7 over, and I end up with 3x equals 12, which when I divide, x equals 4. Now, here's the only thing that is different about logs, and that is logs have restricting domains similar to that of square roots, which means that just like square roots can't have a negative in there. The same thing with logs, you cannot take the log of a negative number. So you can go ahead, try in your calculator, put log and any negative number in. You're going to get an error saying that there's a non-real answer. So because logs have restricting domains, we have to actually check and make sure that the answers are valid, that they do work within the problem. So what you're going to do is take your answer and plug it back into both logs, just making sure that whatever's in here is not a negative number. So if I plug 4 into here, 4 times 4 is 16, minus 7, okay, positive number, I don't have to worry about it. 4 in here, 4 plus 5 is 9, positive number. So that means that this solution checks out. But don't forget to check your answers. Okay. Here's another one. Say they have the same base 3. So what we can do is we can just set whatever they're logging equal to each other. So I have x squared minus 14, that is a minus 14, equals 5x. And you probably cringed a little bit when you saw this. Yes, this is a quadratic. So we do need to get everything to the same side. So I'll have x squared minus 5x minus 14 equals 0. Now, nothing's going to be super crazy if you ever get a quadratic. It'll always be factor. Well, we're not going to make these crazy tedious for you. But this quadratic, just like any one that you would see, is going to be factorable. So this does factor, multiplies to be negative 14 and adds to be negative 5. It's x minus 7 and x plus 2. You then set them equal to 0 and get solutions of 7 and negative 2. So once again, we have to verify these answers work by plugging them back into the logs and making sure we don't get a negative answer. When I plug in 7 into here, 7 squared is 49 minus 14 is a positive number, so that works. 7 into here, 5 times 7 is 35. Yep, positive number. But when I put the negative 2 in, negative 2 squared is 4. 4 minus 14 produces a negative in the log. So that can't happen. Therefore, this actually is not an answer, and only x equals 7 works. Okay. Here, this is going to use some of our properties. You can only use the property of equality, meaning one log equal to another log, if there is only one log on both sides. So the fact that we have multiple logs on this left-hand side of the same base means that we need to use our properties from a previous lesson to combine these into one single log. Now, because I have subtraction, that means that I can use the property, the quotient property, to change this over to division. So what this left side will be is log base 6 of x minus 3. Oops. There you go. Over 4. Equals log base 6 of x plus 2. Now that I have one log on either side and they both have the same base of 6, I can actually just set these equal to each other. So I'll have x minus 3 over x minus 3 over 4 and x plus 2. Solve for x. I need to get rid of the fraction, so I'm going to multiply that. I have to multiply this whole side by 4. So I have x minus 3 equals 4x plus 8. So I'll subtract the x over, subtract the 8 over here, and so I get 3x equals negative 11. Divide by 3, and I get x equals negative 11 thirds. Once again, we have to check and make sure that this does not produce a negative in our log. So if we take negative 11 thirds, or it's negative 3.33333, and I plug it into the first x, negative 11 thirds minus 3 is not going to give us a positive number. It's going to give us a negative number. And therefore, since this is the only solution that we got, there is no solution. Okay, that happens. So that's the property of equality. The other property here is solving logarithmic equations using exponential form. Basically, if you have a log on one side, you can change it to exponential form and solve it using exponential properties. So for example, if I have the log right here, log base 3 of 10x minus 9 equals 4, if we change this to exponential form, then we can actually solve the equation. So remember, if I change a log to exponential, if you remember, I know it's been a few cycles here, but remember, you start with your base and work counterclockwise. So 3 to the 4th equals this, equals 10x minus 9. Well, 3 to the 4th is 81, right? Yep, 81. equals 10x minus 9. I then just add the 9 over. That is a 9. And I get 90 equals 10x divided by 10. And I get x equals 9. So when you have only a log on one side of the equation, in the previous examples we had logs on both sides, so we used the property of equality. Because we only have one log on one side, we change it over to exponential by starting with our base and working counterclockwise. We do have to, because we're dealing with logs, we do have to check and make sure that this does work. So by plugging 9 into x, we get 10 times 9, which is 90. 90 minus 9 is 81. So it is a positive number. Therefore, this solution works. Okay, let's try one more on this page. Again, here's an example where we, because these both have the same base, both same base 10, we can use our log properties. Because this is addition, that means we can change these over to multiplication and combine them into one single log. You can't solve a logarithmic equation if there are multiple logs on the same side. I've told you this before. So we need to combine them into one single log. Because it's addition, I'm going to multiply. So I got 2x times, so, well, first of all, let's do the log. Log of, now 2x times x is 2x squared. 2x times negative 5 is negative 10x equals 2. Now I can use the exponential form to solve this. Since it did not tell me what the base was, we assume it to be 10. We start with the base, 10, go counterclockwise, squared equals, what's in here? 2x squared minus 10x. 10 squared is 100. And then, yep, you guessed it, we have a quadratic. So I do need to move some things around. I'm going to move the 100 over to the right-hand side. So I have 0 equals 2x squared minus 10x minus 100. So if I factor out the 2, if I just divide everything by 2, I get x squared minus 5x minus 50. And yes, once again, this is factorable. Like I said, we're not going to go too crazy on you here. But there is two numbers that multiply to be negative 50 and add to be negative 5. And that is negative 10. Oops, I don't know why I wrote it like that. X minus 10 and x plus 5. So that when I set those equal to 0, I get x equals 10 and x equals negative 5. We're going to check and verify that those answers do work. So if I plug in 10 in here, 2 times 10 is 20, that works. A 10 into here, 10 minus 5 is 5, that works. So the 10 is a valid solution. Negative 5, if I plug in negative 5 into the first one, 2 times negative 5 is negative 10. Right away it gives me a negative answer. Therefore the negative 5 doesn't work and only 10 works. Okay, we're just going to try a couple more questions here. We're not going to do all of them, but just to show you some more examples. Okay, well, here's the back side. Let me zoom in here so we can see all these. So a lot of them are the same. Number 3 is the same thing. You have to use the log property to multiply, because it's addition. You have to multiply those and then change it over to exponential form. It's exactly like the previous problem. So you can look at the previous problem on how to do that. This one's a little bit interesting here. Kids sort of see this and go like, what the heck? There's like 3 terms in there. It doesn't change anything, because there's only one log on one side. I start with my base and work counterclockwise. 2 squared equals, what's in here? X squared minus x minus 6. 2 squared is 4, so I'll subtract the 4. Oops. Subtract the 4, subtract the 4. Because I got a quadratic, everything has to go to the same side. And you can solve it. You can solve it that way. Oh, I forgot about this one. There's supposed to be a typo. There was a typo here. That's actually supposed to be a 9. Sorry. There was a typo, and I just forgot to tell you. I was wondering what the heck. That didn't seem right. Yep, that's supposed to be 9x, which means this is supposed to be 9x, which means this is supposed to be 9x. And now it's factorable. What multiplies to be negative 10 and adds to be negative 9 is negative 10 and positive 1, which means that you get x equals 10 and x equals negative 1. Plug those in, make sure that they both do work, and it turns out that both of them do work. If you plug in 10, 10 squared is 100, minus 10 times 9 is 90, so it's 10 minus 6 is 4. So this works, and you can verify it. Negative 1 squared is 1. Negative 9 times negative 1 is 9, so it's 10 minus 6 is 4. So they both give you the same value there in the log. They're both positive, so both answers actually work. And then I think it's pretty much it. The only thing that you might see, like with logs, is that for some reason kids forget what the base is for a natural log. They both do have a base of e. So and because they both have the same base, I can multiply those. So it'd be the natural log. I may even throw in the base e just so you remember that it's there. X times x is x squared. X times negative 2 is negative 2x equals 5. So what ends up having to happen here is, you start with your base, and then counterclockwise, e to the 5th equals x squared minus 2x. You would take e to the 5th, which is some decimal, and then you'd move it over. This is more complicated than you would see on any test or quiz. Not that it's more complicated. You would just get a decimal, and you would have to use quadratic formula, and it's just a lot of extra work. But just so you understand the process, that's how it works. If you have a natural log, it's the same thing. And then 6 is a regular log. Again, you have to combine. You see a pattern here. We've got to combine these logs because they have the same base and it's addition. I multiply those, so I get 9x squared, well, log base 3 of 9x squared equals 2. And then so I start with my base, 3 squared equals 9x squared. 9 equals 9x squared. Divide by 9, x squared equals 1. And when you take the square root of both sides, you get x equals plus or minus 1. So we do have to check and make sure that those do work by plugging 1 and negative 1. There's only one value of x. I have to check. I don't have to worry about this log because there is no x value. But this one, if I plug in 1 squared times 3 is 3. Negative 1 squared is 1 times 3 is 3. So both of these solutions work as well. That's Unit 7, logs. Please let me know if you have any questions. And that's it.